So we're on page 23. We're starting topic 7, which is titled Slope and Equations of a Line. And we're going to break this down into basically 6 parts. One of the characteristics of a straight line is the slope, so we're going to look at the slope. Another characteristic of a straight line is the y-intercept, which is right here. Then we're going to look at 2 ways to obtain the equation of a straight line. So we can use either the slope-intercept form. In other words, if we're given the slope and we're given the intercept, we can calculate the equation of the line. And if we're given a point and we're given a slope, then we use a different equation and we still come out with the equation of the straight line. It's in a different form, but it still is the equation of a straight line. Then we're going to look at characteristics of straight lines, and different lines, whether the lines are parallel or whether the lines are perpendicular, what criteria we use to distinguish between a parallel line and a perpendicular line. So let's get started first of all with the equation of a straight line. The equation of a straight line is that y equals mx plus b. Y and x represent an ordered pair, and m is the slope and b is the intercept. So this is the simplest form. There are other forms. Now what is m right here? M is called the slope, and it's defined as follows. It's the change in y over the change in x. This little delta here, if you look at the bottom of page 23, you'll see that it means a change in. So delta y means a change in y, delta x means a change in x, and m is the change in y divided by the change in x. Now how do we calculate this? If we know 2 ordered pairs that lie on the line, here for example we see the ordered pair x2, y2, and here we see the ordered pair x1, y1. So these are 2 points that lie on the line. Given that we know the values of x2, y2, and x1, y1, then go back to the definition of m, which is the slope, change in y over the change in x. It's y2 minus y1 over x2 minus x1. So right over here, if we take the y values, y2 minus 1, y1, and we subtract by x2 minus x1. So to get a picture of what the slope actually means, another way of looking at the slope, if we had this, here we've got a ladder, let's say, that's set on a building. Here's the building, the height of the building. Here's the base of the ladder to the base of the building. Then one way of looking at the slope is that it is this delta y, which is, here we've got the top of the ladder, bottom of the building, so how far along it lies on the building, and this part would be how far the bottom of the ladder is to the base of the building. So one way we can look at this is to call the change in y the rise, right over here, and call the change in x the run. So the rise over the run is the slope. Just a different way of looking at it. And we take these situations, 3 ladder situations. Imagine we keep moving the ladder closer to the base of the building and higher up the wall. So here we've moved the ladder from here to here. We've moved it closer to the base of the building, and it extends further up the wall, and we even shorten the distance right over here. So we can see as we go from here to here to here, because the slope is the change in y over the change in x, the y increases and the delta x decreases. So since the slope is delta y over delta x, the slope as we go of this line right here, the slope of this line as we go from here to here to here is increasing. So it's just a different way of looking at it. Now, slopes can be negative as well as positive. Let's take two examples. Consider the line, the yellow line here, this yellow line here, that contains the points 2, 4, and 6, 10. So we have this yellow line. Here's, let's say, the point 2, 4, and here's the point 6, 10. So m, the slope, is the change in y over the change in x. So 10 minus 4 over 6 minus 2. Here this means the change in y. We call this y2. 10 minus 4, 4 is y1, divided by x2, 6, over minus x1, 2. So here we have 10 minus 4 over 6 minus 2. This is 3 over 2. And 3 over 2 is a positive number. It's greater than 0. Now consider, let's look at the blue line. Two possible points on this would be 1, 4. So let's say x is 1 and y is 4. And another point would be 4, 2. Let's say it's right over here. Let's say x is 4, y is 2. And when we calculate this one, same kind of thing. We say 2 minus 4, the difference in the y's, over 4 minus 1. So 2 minus 4 over 4 minus 1. This gives us a negative number. So now we see how a slope can be positive or negative. This one, the first one we talked about, has a positive slope because the m is greater than 0. This one is a number less than 0, and so it's a negative slope. The lines with a positive slope are slope upward. So this is a positive slope. It's sloping upward, whereas this is a negative slope and it's sloping downward. So that's a little bit of information on the characteristics of slopes and how we calculate them. So we go to the next page. One characteristic of a straight line can be where the line crosses the y-axis. Here is the y-axis, and at this point right here, x is 0. So we have 0 here, and we're going to identify the point at which it crosses the y-axis as b. So now, in the first part, we showed how m is calculated. In the second part, if we know the y-intercept, if we know where the graph crosses the y-axis, that's the point b, and we can put in the value b. So this point has the coordinates 0, b. We just call b, we define b as the point at which it crosses the y-axis. Note that where b crosses the y-axis, x equals 0. Let's say, for example, we have an equation 2x equals minus 7. Now, x equals 0 where it crosses the y-axis, where the line crosses the y-axis. 2 times 0 is 0, minus 7 is minus 7, so b equals minus 7. So you can see right over here, the y-intercept, or b value, is 0, minus 7. Now, we don't really need to do this, but just to show you how we've done this before, we've only got one point here. If we wanted to calculate another point, we could calculate the x-intercept, where the line crosses the x-axis. So at this point along this line, y is 0. So 2x minus 7 equals 0. And x becomes 7 over 2, or 3.5. So now we have the x-intercept and we have the y-intercept. We can draw the line. But what we're trying to show here is if we know where the straight line crosses the y-axis and we can identify this point, then we put this into the equation. If we know the slope and we know the intercept, we know the slope and we know the intercept, then we know the equation of the straight line. So there are two ways of obtaining the equation of a straight line. We can use, if we know the point, we know a point that lies on the line and we know the slope, then we can use this equation here, which is really just a difference in y over a difference in x. And we can solve this equation, or we can get rid of the denominator here and simplify it so there's no fraction and write it like this. So this and this are the same. So how do we do that? Well, we start with this equation here. Then to get rid of the denominator, we multiply both sides by x minus x1 because we want to get rid of this denominator. So we multiply the left side by this, and we multiply the right side by that. And that's what I've done right over here. So what happens, this cancels with this, and we get the other form of the equation, y minus y1 equals m minus x1, which has no fraction. So if we know the slope and we know an ordered pair that lies on it, x1, y1, so if x1, y1 is a point on the line, we know the slope and we know x1 and y1, we can get the equation of a straight line. That's why it's called the point-slope form. So the point-slope form, probably the easiest equation to use is this one right over here. Now, supposing we know that a line has a slope of minus 3 and goes through the point 1,4, we can obviously use this equation right here, the equation that I've just talked about right here. So we substitute into this. We know that the slope is minus 3, so m is minus 3. And we know that the point 1,4 lies on the line, so we put y1 equal to 4, x1 equal to 1, and we get this. Now, if we simplify this and transpose the minus 4 over to the right side here, right over here, minus 4 from the left to the right, and we use the distributive rule, minus 3 times x gives us minus 3x, minus 3 times minus 1 gives us plus 3, and we transpose the minus 4 from the left to the right, we get that. We get y equals minus 3x plus 7. Now, you'll notice that if we use this equation and we substitute x equal 1 into the equation right over here, then y equals 4, fulfilling condition that the line goes through the point 1,4. So if we put x equal to minus 1 here, we get minus 3 times 1, which gives us minus 3. Minus 3 plus 7 gives us 4. So what we're saying is when x equals 1, y equals to 4, and that's what should happen if we use the 0.14. Now, if we apply a case where we know the slope and intercept, we can apply this formula to the above equation. For example, supposing we're given m equals 4 and the y-intercept is 6. Well, minus 6. Well, what we really know when we're told that the y-intercept is minus 6, that we have a point 0 minus 6. So we have the slope and we have a point. So we can go back into this equation and use it here. So, for example, in this case, we know that the slope is 4 and the y-intercept is minus 6. We know that the point is 0 minus 6. So we put 0 into the x1 right here. So 0 goes into the x1. And minus 6 we substitute into the y1. So we get y equals 4 minus 6. So even though we know m and b, and we could plug it directly into y equals mx plus b, because we would get y equals 4 and b equals minus 6, we can do the same thing by considering it as a point and using the point slope form. So whether we use the slope intercept form or we use the slope point form, we get the same answer. Okay, so the other way of obtaining the equation of a line is if we know the slope and the intercept. And here again, we've got a delta y over a delta x equals m, and we're substituting the intercept into this equation, which means that the x is 0 and the y is equal to b. And we get this simplified form of the equation y equals mx plus b. If we know the slope and we know the intercept, we can get the equation of a straight line. Now, how do we go from here to here? Well, it's the same kind of thing that we did in the last case, method 1. We're going to get rid of this fraction x. So we're going to multiply both sides by x. So here I multiply the left side by the x and the right side by the x. This x cancels. We get y minus b equals mx. I just reversed x and m and put mx. And then I transpose this over here. So the two basic equations, this is the second equation that we can use to obtain the equation of a straight line. So given the slope and the intercept, we can find the equation of the line. If m equals 4 and the y-intercept is minus 6, then the equation of the line is y equals 4x minus 6. So if we just go back for a few, what we've done is shown, to review what we've done, we've shown the two main characteristics of a straight line are the slope and the intercept. And if we have the slope and the intercept, we can calculate the equation of the line. If we have a point and a slope, we can still get the equation of a straight line using this form right over here. We showed the derivation of this. And either one of these equations can be used depending on what the information that's given. Now, one of the characteristics that we want to look at is parallel lines and perpendicular lines. So let's go ahead and look and give a little more information on parallel lines. Okay, here we see parallel lines, and we see two lines here that are parallel. And you'll notice one thing that's characteristic of these is that the position at which the two parallel lines intersect the y-axis is different. The only difference, the lines 2x plus 1, 2x minus 2 are parallel since their slopes are both the same. So parallel lines have the same slope. So that's one thing that we know. Two lines with slopes m1 and m2 are parallel if and only if m1 equals m2. So here, if we look at this equation, m is 2, and we look at this equation, m is 2, the only difference is in their b values. And their b values are characterized here where they cross the y-axis. So what we can say about parallel lines is, first of all, they have the same slope. How do they differ? They differ in where they cross the y-axis. For example, this B1 might be this number 1 here, and B2 might be this number right here where it crosses right over here. So that's the characteristic of parallel lines. Now let's go to two lines that are perpendicular. What do we mean when lines are perpendicular? Here's one line right here. If another line crosses this line and makes an angle of 90 degrees, you see this little square here, that represents 90 degrees. So if you see that little square made here, or little indication of two lines right here, that represents 90 degrees. So how are these related? Well, if M1 is the slope of one line and M2 is the slope of the other line, the product of these two slopes will be -1. Let me repeat that. If I know the slope of this is M1, and I call the slope of this M2, the product of their slopes must equal -1 if the two lines are perpendicular. If the two lines, we multiply the product of their slopes, and it doesn't equal -1, then the lines are not perpendicular. Now, quick way to apply this formula. Suppose we have a line of slope 2, which is really 2 over 1. To find the slope of a line perpendicular to it, we take the reciprocal and change its sign. What does that mean? Reciprocal means turn it upside down. So put the 2 from the numerator to the denominator and put the denominator here to the numerator. So just flip it. 2 over 1 becomes 1 over 2, and then change its sign. So we put a minus in front of it. The reciprocal of a number means turning it upside down. Put the denominator in the numerator and the numerator in the denominator. Well, let's take another example. Supposing the slope of one line is -3/4, and then a perpendicular line to this, if it were perpendicular, would be +4/3. Note that the product M1 times M2, we multiply -3/4 times 4/3, then the 3's would cancel, the 4's would cancel, we multiply these two and we would get -1. The lines y equal to 3/7 plus 4 and y equal to -3/7 x minus 2 are perpendicular. Why? Because if I take 7/3, I put the 3 from the denominator to the numerator, and I take the 7 and I take it from the numerator and put it on the denominator, and then I change the sign, these two are perpendicular. So we've looked at the characteristic of parallel lines. We've looked at the characteristic of perpendicular lines. And this completes the introduction to the theory on straight lines.